Hello guys and welcome back to CS with Mr. G. This is lesson 3 of our programming unit, where so far we have looked at the basics behind programming and also our first building block of programming concepts, which was selection or conditional statements, which if we think back to last lesson, are what we call if statements, using the words if, elif and else. Today we are looking at iteration, which is our next building block into programming, and the term iteration basically covers what we call loops, which we have discussed in Unit 7, but only using pseudocode. But today we're going to create the 3 loops that we should know using Python, looking at count-controlled loops, precondition loops, and post-condition loops. So we'll tie our knowledge in from Unit 7 with our programming techniques that we've learned this far, and to see how we write lines of code in order to iterate and perform what we call a loop in order to repeat lines of code. So just a quick reminder, so when loop structures are used in programming, and like I've mentioned, it's when we perform this word iteration, which in other words is to repeat. So when a section of code is repeated, this is what we call a loop, and there are many different scenarios as to which type of loop you would use and when you would want a loop to stop running. If you can remember this from Unit 7, then great. If not, let's have a quick recap and we'll look at count-controlled loops, which are for a set number of iterations, so when we know how many times the loop should run. A precondition loop is when we check the condition first, which may have no iterations whatsoever, and a post-condition loop checks the condition after the loop and will always have at least one iteration. So they are the definitions of each loop, and then what we will do is we'll look at how we create each loop in Python and run some sample code to see how it works. So first things first, we have a count-controlled loop, and a for loop was the technique that we used in pseudocode in order to perform a set number of iterations. When we know how many times a loop needs to run, we would use a for loop as we decide how many times it runs. So the keyword that we used in pseudocode was for, as you can see there, and Python uses the same word but in lowercase and is followed by some kind of placeholder name, in which this case I've called a counter. And then rather than the assignment statements that we've seen in pseudocode, which was an arrow and then 1 to 5, we use the words in range, which as you can see have changed color. And then rather than putting 1 to 5, we put our first and last numbers that we wanted to loop from. So the first time this loop runs, counter will be set to 1 and it will iterate until it reaches 6. So as you can see, range 1, 6 means that a sequence of numbers starting from the number 1 and going up to 6, but not including 6. So basically this code will print out our counter, which on the first loop is 1. So it will print the number 1, then it loops back around, will print the number 2, so on until it gets to 5, and then it will stop running. So this program would have simply printed out 1, 2, 3, 4, 5. Notice that it reached the end of our range and then stopped running. So this line here is what we call initializing. It initializes the loop, and it's where we set our counter for how many times this loop will run. So for example, if we wanted to run 10 times, we would do 1, 2, 11 in brackets like this. Like I've mentioned in pseudocode, it would be 1, 2, 10, but in Python, it's a little bit different and we do need to get the hang of it. So just to confirm, the first time this loop runs, counter is set to 1. So this print statement here will print out the number 1. The second iteration, counter is now 2, so it will print out the number 2. It will continue until it reaches 5 and then stop, as the counter will become 6, but this tells the loop to stop running and it doesn't include 6 in its loop. So just bear that in mind when you know how many times you need to loop, and of course you can have a play around with the numbers just to check how many times it loops when you test the program. So let's give this a quick go in Python. For counter in range 1, 6, ends with a colon, and then as you can see, the next line indents. I use a simple print statement and I print out the counter. I give this a quick run. And as you can see, it prints out 1, 2, 3, 4, 5 in the correct order. What you might see across different websites or across different videos is that this placeholder here is often referred to as simply I. And I is a common technique used in programming, as the letter I is short for iterator, like that. So iterator is another word used to determine how many times the for loop will run, but as long as this name here is the same as this one here, they are both the same, so it would perform the same action. What we can also do in Python is we can decide how big the incrementation is. So each time it loops around, how big the number jumps when it's counting to the upper limit. So in this example here, you can see I've added a 3 to the end. So now I've got 3 numbers inside the brackets. And what I've done, just to make it a bit easier to understand, I've changed this one to a 7, so it should loop 6 times. But the 3 indicates how big the number is going to jump by. So it will still start at 1. 7 is the end point, so it will stop when it gets to 6. But 3 is the increment. So the output should hopefully be 1, and then it jumps up to 4. This should be output. And then the next one would be 7, which means the loop will have stopped anyway. So again, let's give that a quick try. I'm going to leave this as J, and I'm going to change the 6 to a 7, add a 3 to the end. And as you can see, 1 and 4 are printed out. If we want a bigger number, let's change this to 100. Let's run it again. And as you can see, it prints out in increments of 3. And you can do this with any number. You can change this to 5, do the 5 times table, and increment by 5. And again, if you play around with these numbers, you can change the range from 0 to 99. And this essentially prints out your 5 times table. But as you can see, it stops at 95 because I've told it to stop at 99. If I change this to 101, it should print out the 100. And there you go. So the times table goes all the way up to 100. So have a play around. But as long as you can understand the basics and what's going on with these 3 values inside the brackets, hopefully that explains a for loop. The following 2 loops, condition-controlled loops, are used when we don't know the number of iterations, but we have a condition that would stop the loop from running altogether. Now, just a reminder, we have a precondition and a post-condition loop. So precondition loop may have no iterations as we check the condition before the code is run. So in pseudocode, it's called while, and while a condition is true, which would go in this slot here, we run the code. So if a condition isn't true, we may never run the code inside, and this is important for a precondition loop. When it comes to a post-condition loop, there will always be at least one iteration as the condition is at the end. So the program won't know the condition until it's ran this code at least once, and then it will check. So if we focus on a precondition loop first, using the word while, in Python, the keyword is also while, and the condition goes at the beginning. Now what this code does is very similar to the previous example, and essentially what I've done here is created a variable that contains the number 10. This is labeled as start. And while start is more than 0, I'm going to print out what's stored in start and then -1 from it. So in pseudocode, it would look very similar. I'm just going to jot down next to it. It would be start arrow 10. So this is directly transferable into pseudocode. And then what I would say is while in capital letters, start is more than 0, output start. So you can see the similarities to pseudocode. And then finally, I would do start equals start -1. Okay, so the reason why I've explained that in pseudocode, as in Python, we can shorten this statement by just using -equals, which is the same thing as doing start equals start -1. And the same thing applies if you're adding numbers. You could do count plus equals 1, which will be the same as count equals count plus 1. Okay, so this is specific to Python, but it is a little shortcut if you wanted to try that. So as you can see, some notes there, start -=1, literally just decreases the start variable by 1 each time it runs. The final output should print these numbers in this order, as start is 10 at the beginning and then -1 each time. Let's give that a quick run in Python. So we'll create our variable called start and we'll set that to 10. And while start is more than 0, we're going to print start and then -1 from it. We could do -=1, or we could do start equals start -1. This is the pseudocode version, and this would be the Python version. So let's run that, and hopefully it runs from 10, 9, 8 all the way down to 1, while start was more than 0. So the key thing here, guys, is that the condition is before the loop starts. Once the loop begins, it runs the code inside, keeps checking on the condition every time it loops around until this condition is met, which will then finally stop the loop from running. Just as a measure, we can flip this round and we can say start equals 0, and we could say while start is less than 11, print start, and then this time we will plus equals 1. And then this will be the absolute opposite, and it'll print from 0 up to 10. We could set start to 1. This would do the same thing. 1 to 10. Again, the conditions at the beginning. Or we could even say while start is not equal to 10. And then because start is 1 on the first loop, this should run. And again, it stops when it gets to 10. So by all means, guys, have a play around. Try and get used to this structure and the syntax of loops. But again, this is a precondition loop as it checks the condition before the loop begins. And the final loop we had was a post-condition loop, which unfortunately doesn't actually exist in Python, but we still do need to understand the logic behind it and know that the condition is after the code inside the loop. So in this example, we repeat until, and you need to know the exact structure in pseudocode. You need to realize that this code will run at least once because the condition will check at the end. And like I said, this structure doesn't actually exist in Python. But what we could do is use what we call a while true loop. So while true, so we'll print start, then we'll increment it by 1. Then we can perform a check and we'll say if start is equal to 10. And if it is, we will break the loop. So this is kind of the same as a post-condition loop, as this will loop at least once. And of course, before we can use the more than sign. So if it's more than 9, which means equals to 10, give that a run. Again, it stops when it gets to 9. Now, why this code will run at least once is because if I change this to 100 and run it, you can see that 100 was printed out here. So start is set to 100, and the print statement inside the code was ran one time. Okay, look in the terminal window, it was run once. Now, what happened then is that I still incremented it by 1. I still added 1 to start. So at this point in time, start would have been 101. But then I performed a check and I said if start was more than 9, which it is because it's 101, I performed this break, which means to stop the while true loop from the beginning. So this is probably the closest we can get to a post-condition loop in Python, but I wouldn't stress too much because like I keep saying, just knowing the definitions of these 3 loops and being able to read and write them in pseudocode is where we need to be for our paper 2 exam. When it comes to the Python logic, so the Python structure for a for loop, and of course a while loop, this will help you when it comes to writing programs in Python, and of course in some of the questions in paper 2, but you can always look to pseudocode if you are more comfortable with that. And just to finish off, guys, what we have is a scenario-based question, and what we can do is put our skills and knowledge of loops into a program that would actually make sense. And so you can see how iteration might be used in a scenario that you might find in the real world. So in our example, we've got a theme park, and in this theme park, it charges visitors for a go of the ride. Each ride costs 3 tokens, and every visitor to the park starts with 15 tokens. So what you should start to do is pick out some of the variables that we'll need, realize some of the concepts that we'll have to create. Then we'll give the visitor the option whether they want to ride again or stop in this theme park. So you should start to be able to pick out where you're using if statements, where we will use a loop, and we will write a program using a while loop to simulate this theme park, asking them if they want to keep riding or until they run out of tokens. So there's 2 conditions where this program will stop: when they run out of tokens or when they manually decide to stop. Then we're going to write a program using a for loop to simulate 5 friends, each spending all of their tokens, and then print out how many rides each friend takes. Okay, so question 1, let's start off. If we remember, the amount of tokens that a user had was 15. So the first thing I'm going to do is create a variable called tokens and assign that variable the value of 15. Then if we remember, each ride costs 3 tokens. So whilst the user has more than 3 tokens, they are able to use the ride. So that should start to trigger in your mind what kind of loop you would use. And what we're going to do is we're going to say while tokens is more than or equal to 3, we can then start to write code which will be true as long as they have 3 tokens. So in our case, when they have more than 3 tokens, they are still able to go on a ride. So what we can do is just print out a basic statement and tell them you have the variable name tokens, and then tell them how many they have left. Now, string concatenation we haven't discussed yet. That is later on in this unit. But what you can see I've done is I've put the plus signs and then put the variable name in the middle. Now, what I have to be careful of is because tokens is storing an integer value, this plus sign is when we are concatenating a string. So what I have to do is convert this variable into a string, but only temporarily, just while I print it out in this statement here. So this will temporarily convert tokens into a string. And then if I just run this really quickly, we're stuck in a loop because tokens is more than 3, and this will loop infinite times as this condition is true. Okay, so let's change our code a little bit more. Then what we're going to do, we're going to give the user a choice, and we're going to say, do you want to ride again? And then prompt them to type in yes or no. Then when they type in their answer, this will be stored in the variable choice. And then I check if choice is equal to yes. And if it is, I take 3 tokens off them. So in order to take 3 tokens off them, I say tokens equals tokens minus 3. Or if you remember from before, I could have just done tokens minus equals. This will do the same thing, but I will put tokens equals tokens minus 3 just for clarity. And then just give them a little statement saying print, enjoy the ride. So I run this now. It says you have 15 left, and just fix this code here, give this little space. And then I missed the word tokens here. Stop that, run it again. Okay, so you have 15 tokens left. Sorry, again, let me put a space there just to make it nice and neat. So you have 15 tokens left. Do you want to ride again? If I type in yes, enjoy the ride, you have 12 tokens left. If I keep pressing yes, it keeps minusing 3 as this condition is true. And then hopefully, once I get to less than 3, the program stops and our precondition loop finally meets the condition of tokens equaling a number less than 3, and the loop stops. What I didn't do, which is just good practice, is put an else statement or elif choice equals no. Then I will break the loop, and hopefully this will stop the loop. So if I type in no, the loop stops, okay? Or likewise, I could just put else, and this way, whatever you type in, even if I typed in the word cheese, the loop breaks as it's anything other than the word yes. Okay, so there you have it. We've combined our precondition loop and a conditional statement, our if statement, to make our simple program. The next question is to use a for loop. And as you can see, this is going to loop 5 times to simulate our 5 friends, all spending their tokens, which is 15. And then print how many rides each one has taken. So again, we're going to have to borrow a technique used from an earlier lesson. And in this one, we will start with a for loop. And what we'll say is, we could say for I in range, but just for practice, I'm going to put for friends in range so you can see the difference. Okay, open brackets, and then it's 5 friends. So we're going to go from 1 to 6, and this will stop, if we remember, at 5. Don't forget your colon at the end of this line. As you can see, it indents. We've got our tokens, they equal 15. I'm going to create a variable called rides, and this will count how many rides each friend has been on. So I'll set this to 0. If you wanted to, you could call it something like rides counter. And then what I'm going to say is while tokens is more than or equal to 3, just like before, tokens equals tokens minus 1, and rides counter equals rides counter plus 1. So this simulates that every time they go on a ride, we count 1. We add 1 to the counter that they've been on a ride. And this will loop as long as they have more than 3 tokens, just like before. Then once they've run out of tokens, I'm going to say print, and then rides counter were taken today. Remember from earlier, I need to temporarily convert this into a string. So I convert this to a string. I concatenate my message, and then I put a space here just to make it nice and neat. And then I say how many rides were taken today for each friend. So I run this, and as you can see, 13 rides were taken today. To make this a bit more understandable, what I'm going to do, I'm going to rewrite this, and I'm going to put friend in speech marks as it's a string. And then I'm going to refer to this friend as a number. And then what I'm going to do is I'm going to use the counter from the for loop here to indicate which friend number it is. So for example, if I put friend here, spelled the same as friend in our loop, what this should do on the first loop is print out friend 1, and then I'm going to say took this amount of rides. Again, I need to just temporarily convert this to a string. And when I run this, what should happen is it should print out friend number 1 took this amount of rides. It'll loop around to the second friend. Friend 2 took this amount of rides, and so on. Let me just make it neater again. Let's retry that. So friend 1 took 13 rides, friend 2 took 13 rides, and so on and so forth. So it simulates each friend. Hopefully you've noticed that this is massively wrong, as it cost 3 tokens per ride, not 1. So technically they should have only took 5 rides each. So there's the final solution. So what we've done here, guys, we've put a while loop inside a for loop, which is quite complex, but hopefully you're starting to understand what's going on inside these loops, and we can start to use them when we are given scenario-based questions. So well done, guys. Hopefully that makes a little bit of sense. And by all means, go and practice these loops in Python. Just give them a go, have a little try. Don't be scared of getting it wrong. And any misconceptions or problems, please let me know in the comments. And thank you for watching, and I hopefully see you in the next video.